gradient, divergence, and curl. So let us first start with gradient. So you know that in one dimension, if you have some scalar function, consider a scalar function f that is function of x only. And let x changes by small value, that is dx. X changes to dx. So what will be change in the function? So change in function f is df, and that is given by this relation. Change in, if x changes by dx, change in function f is df. So this change in function f depends on this term, and that represent derivative of f with respect to x. So this derivative is the proportionality constant in this case. If x changes by dx, change in function f depends on this term. So larger will be this value, there will be large change in function f. And this represents slope at a particular point. That you know, if you can plot f versus x, so at different point, you can locate its slope. So this del f by del x represents the slope at a particular point. And you can see how fast function is changing. Accordingly, you have this value. Derivative, if function is changing very fast, so derivative will be large. If variation is very less, then this value will be small. So that you know in one dimension. But now we have to generalize this in 3 dimensions. So how to generalize this? Let a scalar function is v, that is function of x, y, z. Take another scalar function v. Now that is function of x, y, and z. Now what will happen if you change x, y, z by dx, dy, and dz? If you change x, y, z by dx, dy, dz, again you have to see change in function. Change in function v is dv. So that dv is, mathematically you can write in this form. This is the change in function v. Now we can rewrite this equation in another form. This dv can be also written as in this form. Take dot product of two terms. First term is this. And then take dot product with dx x cap, dy y cap, and dz z cap. If you take dot product, you will get same term. Now this first term defines the gradient of the scalar function v, and second term, you know that this is the dl vector. Second term is dl vector. So how to find gradient in a Cartesian coordinate? So gradient v is del v by del x x cap, del v by del y y cap. So gradient v is a vector quantity. So it has magnitude and direction. And mathematically, you can calculate in Cartesian coordinate using this relation. So from this relation, this is how gradient v calculated in Cartesian symmetry. And we can define here del operator. What is del operator? If you operate del on v, you will get gradient. So this is the del operator. If you operate del on a scalar v, you will get gradient of v. So you know how to calculate it mathematically. Now what does gradient represent? So now I have written dv as gradient v dot dl. So let us rewrite this as dot product of two vectors, because dv is a vector, dl is also a vector. So gradient has magnitude and direction. So you will write this as mod gradient v mod dl cos theta. Now we have to see in which direction change of function v is maximum. So let us fix dl. On a fixed dl, if you search around in different directions, then change in function v will be maximum if theta is 0 degree. On a fixed dl, if you see in different direction, you will see change in the function v will be maximum when theta is 0. So it means gradient v points in a direction of maximum change in the function. Maximum change in the function. So if you move in gradient v direction, there will be maximum change in the function v. Or you can say that is the direction of steepest ascent.
Excuse me, sir.
Yes.
Can you please repeat last line because it's not visible?
It means gradient v points in a direction of maximum change in the function. If you that is the direction of max. If you move in the gradient v direction, there will be maximum change in the function. So that is the direction of steepest ascent or descent. So you have to see in which direction change in the function is maximum. And mod gradient v represents the slope of the tangent planes in that direction. Mod gradient v represents the slope of the tangent plane in the maximum direction. So you know gradient has magnitude and direction. Direction is along which there is maximum change in the function, and mod gradient v represents the slope of the tangent plane in that direction. Now we will see how to calculate gradient v in spherical polar and in cylindrical coordinate. So in spherical polar coordinate, this is r theta phi. So you have to just remember how to calculate it in spherical polar coordinate. So that is del v by del r cap 1 by r del v by del theta cap plus 1 by r sin theta del v by del phi cap. So this is gradient v in spherical polar coordinate. You have to remember this. We have to also calculate it in cylindrical coordinate. So gradient of v is del v by del r cap plus 1 by r del v by del phi cap plus del v by del z cap. So this is in cylindrical coordinate and this is in spherical polar coordinate. So you have to see how to calculate gradient in Cartesian coordinate, in spherical polar coordinate, and in cylindrical coordinate. Now there is one other application. Sometimes you have to find unit vector normal to a given plane. So using gradient, we can find unit vector normal to a plane. So let us see how to find unit vector normal to a plane. Unit vector normal to a, you can say it's a constant plane. Some constant plane is given. For example, that constant plane is represented by v, x, y, z. This value is some constant value. Some constant plane is given and you have to find unit vector at a particular point normal to that plane. So in this case, what will be dv? dv is gradient v dot dl. This will be 0. You can see if v, x, y, z is constant, so dv will be 0. And dv I have written as gradient v dot dl. So now dl is on the plane. So it means gradient V and dl, they are perpendicular. If gradient V dot dl is 0, what does it mean? dl and gradient V, they are perpendicular. So in that case, we can write unit vector that is normal to the plane n cap is simply gradient V by mod gradient V. So this is the unit vector. Unit vector normal to a constant plane. Again, it's at a particular point. At, let's say, at point, any point is given, point A, B, C. At a particular point, you can find unit vector normal to that plane. For example, let's say if you have x by A plus y by B plus z by C. This is some constant plane, and you have to find unit vector normal to this plane. So you can write this as Vxyz is x by A plus y by B plus z by C, and that is some constant value, right, in this form. So what will be gradient of V? 1 by A x cap plus 1 by B y cap plus 1 by C z cap. So unit vector n cap will be gradient V by mod gradient V. So unit vector normal to this plane will be 1 by A x cap plus 1 by B y cap plus 1 by C z cap. And that will be 1 by A square plus 1 by B square plus 1 by C square. Mod gradient of V is 1 by A square plus 1 by B square plus 1 by C square. So this is the unit vector normal to this plane. So if it is function of, let's say, for some other value, if it is function of x, y, z, then you have to ask at what point. So at given point 1, 1, 1, 1, 2, 1, you can easily show the unit vector normal to that plane. Is it clear? Unit
Yes,
vector
sir.
normal to a plane. So just use this gradient V by mod gradient V. So in next class, we will see some other examples in Cartesian coordinate, in spherical polar coordinate, how to calculate gradient of V. You will see in electrostatics, if scalar potential is given and you have to find electric field. So you can easily find if you know how to calculate gradient, because E is given by minus of gradient V. So we will use this when we will talk about electric field E in different coordinate system. ठीक है? So I think you have note down this example, that the height of a certain hill in feet is given by h, that is function of xy. So this is 10 2xy minus 3x square minus 4y square minus 18x plus 28y plus 12, where y is the distance in miles north and x is the distance east of the South Headley. So I have shown it here. Let's say this location is South Headley. So you have to find where is the top of the hill located, how high is the hill, and how steep is the slope in feet per miles at a point 1 mile north and 1 mile east of the South Headley. So now you have to see application of gradient, how to apply this. So you can see height I have given along the z axis. So that is the function h, and that h depends on x and y. So again, at the highest point, gradient will be 0, because around that point, if you move in different direction, there will be no change in the function. That is the, you can say that is the maxima minima condition in this case. So for first case, you have to put gradient of h must be 0. So you have to see solution. So what will first find gradient of h? So this will be 10. So you will get two component, del h by del x x cap, del h by del y y cap. So first term will give you, if you differentiate with respect to x, you will get 2y minus 6x minus 18 x cap. This is the first term, del h by del x x cap. And second term is del h by del y y cap. So that will give you, second term is again plus, you will get twice x minus 8y plus 28 y cap. So this is the gradient of h. And for at the top of the hill, you have to put gradient h must be 0. So if you put gradient h0 in component form, these terms will be 0. 2y minus 6x cap minus 18 will be 0. And second equation will be 2x minus 8y plus 28 will be 0. Now solve for x and y, you will get the point where the top of the hill is located. So just solve x and y. So you will get x is, this will give you x is minus of 2 and y is 3. Both are in miles. So now you can see where is point minus 2 and 3. So you move, this is, let's say, minus of 2, and then you have to move 3 here. So let's take this point as minus 2 and 3. So if you see this point, above the point minus 2, 3, top of the hill is located. So that is, you can say, at point minus 2 and 3, top of the hill is located. And then you have to find height of the hill. Let us find the height of the hill. So you can see top is located 2 miles west and 3 miles north of South Hadley. So that is the point where top of the hill is located. Now you can see this h is function of xy. So you know point where the top of the hill is located. So just put x minus 2 and y3, you will get the h value. So what will be h at minus 2 and 3? Calculate this value. Calculate h minus 2 and 3. So you have to substitute here. This will be twice into minus 2 into 3 minus 3 into minus 2 whole square minus 4 into 3 whole square minus 18 into minus 2 plus 28 into y plus 12. So if you calculate this, you will get this is 720 feet. This value will be 720 feet. So that is the height of the peak, 720 feet. So that is first part. Where is top of the hill is located and how high is the hill? That is second part. Now in third part, how steep is the slope at some other point. Let's say that point is 1, 1. So move 1 point here, 1 here. So this point is 1, 1. Now at another point, you have to find slope. So this part is, this is A. First you have calculated A part. This is B part. And in C part, let us first find gradient H at point 1, 1. So what will be gradient of H at point 1, 1? And then find its magnitude, that will give you slope. So let us calculate it. What will be gradient at point 1, 1? So this will give you 10. So if you put 1, you will get.
Sir, ये 1 1 कैसे आया?
This point is given. How steep is the slope at a point 1 mile north and 1 mile south?
Okay,
1
sir.
mile east. So 1 mile east, 1 mile north. So you
Okay,
have
sir.
another point here.
Okay.
At this point, you have top of the hill is located. That's why its gradient is 0. But you can take another point. At this point, you have to find what will be the steep. How
Okay, sir.
steep is the slope?
Thank
So
you, sir.
first find gradient and then take magnitude. Magnitude will give you slope. So put 1 1 here in gradient H. If you put 1 1, you will get 2 minus 6 minus 18 x cap plus 2 minus 8 plus 28 y cap. So this value will be, this will be, what will be this value? 22 minus x cap plus y cap. This is the gradient. And what will be mod of gradient H at this point? 220 root 2. And this will be approximately 311 feet per miles. So that is the slope at point 1, 1. Now you have to see at this point in which direction you should move so that slope is steepest. So you have to move in the northwest direction, because northwest direction is the direction of the gradient. So if you move in the northwest direction, you will get slope is steepest, because gradient represents the direction along which there is maximum change in the function. So in this case, maximum change in the function is height. There will be maximum change in the height if you move in the northwest direction. So at point 1, 1, steepest slope will be in the direction of northwest. Is it clear or not?
सर रूट टू कैसे आया?
You have to take magnitude.
Okay,
This is the
sir.
vector. So if you take magnitude under root 1 plus under root 1, this will give you root 2.
Okay, sir. Okay, thank
So-
you.
Sir, is the direction is also the normal to this point?
Which point?
This 1, 1, we are finding the direction of steepest
You have
slope.
to, this will give you slope. But at a particular point, you have to decide in which direction slope is steepest. And that direction is the direction of gradient. So, and
Yes,
that
sir.
direction is northwest direction. Even if you see this value,
No, sir. Sir, I'm asking that in last question you have told a formula that gradient of h upon its magnitude is the direction of normal at that point.
no, that I have discussed unit vector normal to a constant plane. That is different case. That I have discussed what is the unit vector normal to a constant plane. So that is different case. Whenever you have to find normal, you have to use that condition. So in this case, slope is steepest in the northwest direction. That is the meaning of gradient. That in the direction of the gradient, slope will be steepest.
Sir, here third question, the point at a point 1 mile north and 1 mile east. So here it is direction like 1 mile north and 1 mile east.
You have another
So-
point. Height
Okay.
of the mountain is varying. So if you calculate peak, that you will get at -2 and 3. Let's say you are at this point. You are at this point, so you can calculate what will be the slope at that particular point. So at
Yes.
that point, if you have to decide in which direction you should move so that there is maximum change, means that will be the steepest value, and that direction is the direction of gradient. So that's why that direction is northwest direction. So at that point, if you move in the northwest direction, slope will be steepest.
Okay, sir. Thank you, sir.
So that is the meaning of gradient, and you can easily calculate gradient in Cartesian coordinate. If any function is given as a function of x, y, z, you can easily use that formula, del v by del x, x cap, del v by del y, y cap, and del v by del z, z cap. So you will get in Cartesian coordinate. Let us take one example in spherical polar coordinate, how to calculate
Excuse me,
gradient.
sir.
Yes.
क्वेश्चन नंबर ए पे जो वहाँ सर वो जो है ना कि वेस्ट एंड नॉर्थ ऑफ द हिल हिल का जो वो जो डायरेक्शन है ना वो एक बार रिपीट कर दीजिए क्वेश्चन नंबर ए पे.
You have to find where is the top of the hill located. So at the top, it's like a maxima minima condition. You know, in maximum minima condition, at top will be slope will be 0. So in this case, you will see this gradient is 0 because around that point there will be no change in the function. So just equate to that value, you will get the maximum point. So I have equated this to 0, and you will get point -2 and 3. So you got that at this point, if you calculate gradient, that will be 0. So that is the, at that point, this height of the mountain is maximum value. And if you put that value in this case, you will get height of the mountain. What will be height at that point? So that is part A and B. Where is the top of the hill located and how high is the hill? And then you have given some another point is given, and you have to find how steep is the slope. Is it?
सर पॉइंट सी डायरेक्शन क्लियर नहीं हो रहा है, प्लीज उसको थोड़ा सा एक्सप्लेन कीजिए.
This point C. Now at this point, if you plot this minus x cap plus y cap, that direction is the northwest direction. You will see this direction. If you see at this point, what will be direction of the gradient? So that direction is northwest direction. You can see from this relation also, minus x cap plus y cap at this point points in the direction of northwest direction. That is the gradient, direction of the gradient.
Oh, got it.
So at any point, if you know direction of the gradient, and if you move in that direction, you will see there will be maximum change in the function. That I have told you in last class also. You have to always move in the direction of gradient, then there will be maximum change in the function. In this case, function is height. So now we will see how to find divergence. Let us see divergence. So again, some vector field is given, and in that vector field, you have to find divergence around a given point. So let us take this vector field. A is ax x cap, ay y cap, and az z cap. So and you know del operator. So divergence of A is defined as del dot A. So del, you know, x cap, del x plus y cap, del y dot ax x cap, ay y cap, az z cap. So this will give you This is the divergence of A. And you have to always see divergence at a particular point. Let's say some point A, B, C is given. Divergence around a particular point. It's a scalar value. So divergence is a scalar value. Now what does divergence represent? So we will take some vector field and then we will see what does divergence represent. So let us take some example. This is the vector field x cap, y cap, z cap. Consider this vector field. And we have also expressed this vector field in spherical polar coordinate as r cap So now we can easily plot this because around a point you have a spherical symmetry. So we can easily plot this. I have taken some simplest example so that you can represent this vector. You cannot represent all vectors, but in simple case, you can represent these vectors also. So just to show you what does divergence represent, I will take simplest case. So around this point, you can see this magnitude of the vector is increasing. This represents r cap. So what does this represent? It means at different point, magnitude of the vector is different. When r is 1, so let's take this is 1 magnitude, then I have taken it as 2 magnitude, then 3 magnitude, because this vector depends on r. So this vector field, for each point, a vector field is associated. So that's why for each point, you have to represent the vector field. So I have shown it by increasing magnitude, because as r increases, magnitude of the vector is increasing. So this is the first case. Now we have next case. In this case, take vector A as z cap. Another example. So now direction is z cap, and in z direction, magnitude is increasing. So let us assume this direction is z direction. So we can represent this vector field in this form. Now in this vector field, around a given point, we have to find divergence. I have represented in z direction, magnitude is increasing. So that represents the vector field z cap. This represents vector field r cap. Let us take third example also. Vector field A is,
Sir, please repeat.
you have to plot vector A, that is z cap. So z cap means direction is z, but at each point magnitude is increasing. So let's say z is 1 unit, 2 unit, 3 unit. So you can represent in this form. Next is, let's say vector
Okay, sir.
field is simply z cap. So in this case, direction it is fixed and magnitude is also fixed. So you have to represent it by constant magnitude. So let us represent it by a constant magnitude. Again, in this vector field, you have to find divergence at a particular point. So just for comparison, we have represented these vector field. Now mathematically, using these relation, you can find the divergence. If any vector is given, you can find the divergence. So let mathematically find the divergence in these vector field. Let us calculate. Here ax is x, ay is y, az is z. So what will be divergence of A in this vector field?
3.
3.
This will be 3. Just put x is x, y is y, so 1 plus 1 plus 1 is 3. In this vector field,
1.
divergence of A is 1. In this vector field, divergence of A is 0.
0.
Now you can compare. Which is the reason of high divergence as compared to other point? That is not the absolute thing. You have to always compare between 2 points, because that scalar value will tell you whether divergence is high or low as compared to other point. For example, in this case, divergence of A is 3. This scalar value is 3. And here scalar value is 1. So you can see this is the reason of high divergence as compared to this point. If you compare
यहाँ
these,
पे 3 और 1 0 ये सब कैसे है सर, प्लीज एक्सप्लेन.
use this formula. In divergence, you have to put ax, ay, az. So if you put x, this value is 1, y 1, z 1. So 1 plus 1 plus 1, you will get 3 here.
ओके सर, ओके.
In this case, this ax, ay is 0, only az. So you will get 1. And this is constant magnitude. So you will get 0. So now if you compare these two vector field, you can see this is the reason of high divergence as compared to this point. This is the reason of 0 divergence. So in a sense, you will easily see, if you see this point, you will understand what is the actual meaning of divergence. So divergence means spreading around a given point. You can see these vectors are spreading. So how a vector spreads from a given point? Spreading means divergence. So that represents the divergence. How a vector spreads from the given point. So this is the reason of high divergence. In this case also, you can see these magnitudes are different. So in that sense, you will see what is coming in and what is going out. So that will be different. That's why you can see you have some positive divergence. In both case, this arrow shows the positive divergence. In this case also, divergence is positive. Sometimes divergence may be negative also. If in this case, let's take it as minus sign, all are minus sign. So you will get divergence as -3. Only direction will be opposite. So negative divergence means convergence. This is the positive divergence. Positive divergence means spreading, and negative divergence means convergence. In this case, magnitude is same. So mathematically, you will get divergence will be 0. There will be no divergence around a given point. So that is the reason of 0 divergence. Is it clear?
Yes, sir.
But in electrostatics and magnetostatics, we will see divergence and curl in terms of field. Fields are, let's say, electric field and magnetic field. So let us see divergence in terms of field. In terms of fields. if divergence is
सर एक मिनट
yes
सर जो आपने कन्वर्जेंस बोला
Neg-
कन्वर्जेंस में डायरेक्शन टुवर्ड्स द पॉइंट हो जाएगी
in this,
तो
if you take
मैग्नीट्यूड
this
क्या
example, negative divergence means convergence. For example, in this case, if you have negative divergence, let's say divergence is negative value. I am taking this example, so that is the meaning of convergence. Just so the direction is opposite, so that will represent convergence around this point. So that is the negative divergence.
I'm talking about magnitude. Magnitude remains the same, means
Magnitude, if you take it
whatever
as
would be
minus
there.
RR cap, only direction will be different. I am taking different example. Let's say this is minus RR cap. That represents the negative divergence. You will get divergence of A is minus of 3. That represents the convergence. Is it clear?
Yes, sir.
Now we have to see what do you mean by divergence in terms of field. So field, we will talk about electric field and magnetic field. So if you see, if divergence is non-zero, then there is some source or sink for that field. And we can also show that monopole exists. For monopole exists, for example, plus Q charge is the source of the field. And minus Q charge is the sink for the field. So in terms of field, if divergence is non-zero, it means there is some source or sink for the field. And you know, in electric field, you have plus Q charge is the source of the field, or you can say electric field lines are diverging. And if you have minus Q charge, electric field lines are converging. So that is, so minus Q charge represents the sink. If you have negative convergence, negative divergence or convergence, so that point is the sink point. And if you have plus Q charge diverging, so that point is the source point. So, and you also know that discrete charges exist. So we say that when divergence is non-zero, monopole exists or discrete charges exist. So that is the meaning of divergence in terms of field. If you have to think in terms of field, you can say that if divergence is non-zero, there is source or sink for that field, and monopole exists like plus Q and minus Q charge. If divergence is zero, then there is no source or sink for that field. Source or sink for that field. And monopole does not exist. For example, in magnetic field, you will see divergence of B is 0. And you know that there is no source or sink for the magnetic field. Magnetic field lines always forms a closed loop. But in case of electric field, they start from one charge and they will end up at the other. So divergence B is 0 means there is no monopole. And you also know that magnetic monopole doesn't exist. So that's why in magnetic field, divergence of B is always 0. So that is the meaning of divergence in terms of field. Is it clear? Monopole exists, you have discrete charges, and monopole doesn't exist. Now we will see. So in this case, I have taken example. In these examples, you can see divergence is some constant value. So around, it means in this vector field, around each point divergence is same. In this vector field, around each point divergence is same. But you can take other example where in same vector field, around different point, you have different divergence. For example,
सर
yes,
सर जो पॉइंट से जो वेक्टर फील्ड निकलेगा सर वो क्या होगा?
किससे?
जो सेंटर पॉइंट से जो वेक्टर फील्ड निकलेगा सर उसका क्या होगा? सेंटर से जो निकलेगा.
No, that I have represented around a given point, and you have to decide what is where you have to start and what is one magnitude. Accordingly, you can draw at different point. I have assumed this is 0.1, this is 0.2, this is 0.3. So that is the vector field.
Okay, sir.
Magnitude you have to decide. I have chosen that this magnitude is 1. Accordingly, you have to choose 2, 3. That you have to decide.
Sorry, for source is point source.
Which one?
Then if source is point source.
I am talking about plus Q charge is the point source. That is the source for the electric field. And minus Q charge is the sink for the electric field. Let us take another example, x square x cap y cube y cap plus z power 4 z cap. So this is some other vector field. Now in this vector field, what will be divergence? So if you calculate, put ax, ay and az, you will get twice x plus 3y square plus 4z cube. So in this vector field, around different point, you have different divergence. So now you have to ask at what point. You have to always ask divergence at what point in a given vector field. So this point, let's say 1, 1, 1. So if you put 1, 1, 1, this will be 2 into 1 plus 3 into 1 square plus 4 into 1 cube. So this will be 9. Scalar value is 9. If you have some other point, so this, let us take another point is 1 to 1 in same vector field. So we will get 2 into 1 plus 3 into 2 square plus 4 into 1 cube. So this will be 18. Let us take some other point. Let's take 1, 2, 2. So this is 2 into 1 plus 3 into 2 square plus 4 into 2 cube. So what will be this value? (46) and so on. So you can easily calculate the scalar value at different point, and then you can compare which is the region of high divergence. So this scalar value will decide which is the region of high divergence. So if you compare these 2 points, around 1 to 1 is high divergence as compared to this point. If you compare these 2 points, so around this point divergence is high as compared to this point. So just by seeing the scalar value, you can decide which is the reason of high divergence. ठीक है? Now we have to see how to calculate divergence in spherical polar and in cylindrical coordinates. So vector A is given in spherical polar coordinate, AR r cap, A theta theta cap, A phi. So again you have to remember this formula, how to write divergence of A in spherical polar coordinate. So this is 1 by r square del r square into AR plus 1 by r sine theta del theta sine theta into A theta, and last term is 1 by r sine theta del phi into A phi. So this is divergence of A, and in this formula you have to only substitute for AR, A theta and A phi. So vector A is given in spherical polar coordinate. This is in spherical polar. Now next vector is in cylindrical coordinate. A phi phi cap and AZ z cap. So this is given in cylindrical coordinate system. Cylindrical coordinate system. So we can write divergence of A is 1 by r del r into AR plus 1 by r del A phi by del phi plus del AZ by. Again in this formula you have to only substitute for AR, A phi and AZ. So let us take.
Sir, is there any method to remember this formula?
You have to remember it. Some formula you have to remember. Just by practice you will remember it. You will get 3 terms corresponding to AR, A theta and A phi, and here you will get AR, A phi and AZ. So just remember this formula. From different examples, you will easily remember how to write divergence. So let us take first example. So example number 1. So A is r cos theta r cap plus r sin theta theta cap plus r sin theta cos phi phi cap. Let us find the divergence of A. So vector A is given in spherical polar coordinate. R cos theta r cap, r sin theta theta cap, r sin theta cos phi phi cap. So this term is AR, this term is AR, this term is A theta, and this term is A phi. So in this formula, just substitute for AR, A theta and A phi. So what will be divergence of A? 1 by r square del r square into r cos theta. And then second term is 1 by r sine theta del theta sine theta into r sine theta plus 1 by r sine theta del phi into a phi is r sine theta cos phi. So just solve this, you will get divergence of A in a spherical polar coordinate. So this will give you, this is 3r square cos theta. In this case, you will get 1 by r sine theta into r common, and sine square theta is 2 sine theta cos theta. And last term is 1 by r sine theta into r sine theta, and cos phi is minus sine phi. So this r square will cancel out, this r sine theta will cancel out, so you will get 3 cos theta plus 2 cos theta minus sine phi. So divergence of A is 5 cos theta minus sine phi. So just substitute for AR, A theta and A phi in this formula, you will get divergence of A. Let us see one example in cylindrical symmetry. So vector A is R 2 plus sine square phi r cap plus r sine phi cos phi phi cap plus 3z z cap. Again, vector A is given in cylindrical coordinate and you have to find the divergence of A. So in this case, AR, A phi and AZ is given. This term is AR. This term is A phi. And this term is AZ. So if you substitute, you will get divergence of A is 1 by R del R, and this term will be R into R 2 plus sine square phi plus 1 by R del phi R sine phi cos phi, and last term is del Z. AZ is 3Z. So let us calculate this. This will be R square will give you 2R. So 1 by R into 2R 2 plus sine square phi. Again this R will cancel out. So you will get sine phi cos phi, take half sine. So that will give you sine 2 phi. Sine 2 phi is 2 cos 2 phi plus 3. So now R will cancel out and this will give you 4 plus 2 sine square phi. Plus 2 will cancel out and cos 2 phi is cos square phi minus sine square phi plus 3. So, and this will give you 4 plus 3, and this will give you cos square phi plus sine square phi. Cos square phi plus sine square phi. This is 1. So 4 plus 3 plus 1. This will be 8. So in this case, divergence of A is 8. So if you remember these formulas, whether Cartesian coordinate, spherical, polar, cylindrical, just put for AX, AY, AZ in Cartesian coordinate, AR, A theta and A phi in spherical polar coordinate, AR, A phi, AZ in cylindrical coordinate, you will get the divergence of A. I think now you can easily calculate divergence in different coordinate system.
Yes, sir.
Yes, sir.